Okay, it is again my pleasure to introduce Andre Boya, who has been working on machine translation forever. I had projects with him for better part of 20 years. We started together actually the Euromatrix project, which was kind of one major project that introduced phrase-based machine translation to for European languages, and we advanced that to syntax-based models. I always heard from the group in Charles University about tectogrammatical things. I don't know if that's still a thing. But as the neural wave has caught on, we also jumped on board of that. The latest wave seems to be speech translation. I hear now from every corner in the world that speech translation is the next big thing, which is the integration of both speech recognition and machine translation in a single model, or however you do this. So he'll talk today about actually what happens if you combine speech recognition and machine translation. Apparently two superhuman technologies. So we'll hear how that goes. So again.
Thanks a lot. It's my great pleasure to be here, and I wanted to give you some live demonstrations as well. But because I feel here as at home, like WMT is my venue, so to say, for the last 20 years. No, WMT not itself, but I took the liberty of not giving a live demo, and in the presentation you will understand why I decided not to give another live demo today. Yes, indeed, I'll be talking about how I moved from plain machine translation text-based to the speech one, and that's because text translation seems too easy, and you hear all these details about being superhuman. So let's go into the lecture itself. So I'm actually presenting the results of a new project that finished this year. The EU project was called ELITER, European Live Translator, and we had the great starting point of superhuman ASR and superhuman MT. In the talk, I will walk you through our pipeline, also timeline of the project, and I'll talk about multilingual machine translation and speech translation in some more detail. And I'll be talking about humans throughout the talk. We are touching upon the interpreters, and actually we want to involve them, include them in the loop somehow. So this is also part of the talk. As I already suggested, machine translation for some languages seems easy, so I'm adding speech. And if speech translation would seem easy, then I have yet a harder task for you to try. So at the end of the talk, I'll invite you to take part in another shared task, not WMT, where the same sequence-to-sequence technology is going to struggle. Okay, so the research project, it's called a Research and Innovation Action. If you are familiar with European funding, it distinguishes between the activities which are generally known how to be done, and you just need to scale them up or put them to practice, that is innovation, and the blue skies research, which is the research. So we promise to do highly multilingual machine and speech translation, of course, building upon the machine and speech translation from the many decades ago. We introduced the high multilinguality as the new thing. And also we focused on document level consistency. The other task that I've already mentioned is automatic meeting summarization. So this project ran for 3 years, and before that, there were not so frequent remote meetings, and there was no such big need for summaries, but we still promised to open that area of research. So that's the automatic minuting. As Philip said, we have been on a number of projects for many years. I don't know if you were still at Edinburgh in 2019. Maybe not, but that's the group. So this project was run by Charles University, University of Edinburgh, Karlsruhe Institute of Technology. And then we had an integrator company, Paravoice, and a remote remote conferencing company, AlphaView, as a secondary user partner. And the whole project was actually initiated by our affiliate user partner, and that was the Supreme Audit Office of the Czech Republic. So they wanted to run a congress for their presidency of this EuroSci Association, the association of the Supreme Audit institutions across Europe. And it was originally planned for May 2020, but then plans have somewhat changed. And they needed to cover many languages. So the language scope is described here. The 24 EU languages by heart, I'm sure. The EuroSci Association needs many more. They need 19 more languages, including Albanian or Azerbaijani or Belarusian, Montenegrin, Moldovan. Some of these languages are so low resource and so politically inspired that even the grammar books are not yet written for these languages. So that is a big difference compared to the EU languages, which have lots of data. So we have these relatively high resource or moderate resource languages, and then the low resource EuroSci languages. And we promise to focus on the three technologies: speech recognition, ASR, specifically English, German, and then other languages needed by the Supreme Audit Institute, and then Czech, because our institute has not worked with Czech ASR beforehand much. So we promise to do a lot there. For speech translation and machine translation, we focused, of course, on the high resource languages, English, German, and Czech, but we covered all EU languages, and we also promised to do all the other ones. And for the summarization, we only did English and Czech. So the starting point. This is the word error rate before neural neural ASR came into business. I'm not an expert on ASR. I'm only slowly learning about the field, but it's essentially very easy to measure the quality of recognition. You just check the number of words that you have recognized correctly. The word error rate is an appropriate measure there. It's very easy to see what is the percentage. And it is said that humans are at about 4% of word error rate when transcribing the speech. In the 1990s, these levels were reached on small small closed tasks in kiosks, kiosk mode, air planning or flight planning conversation. Then it was very hard to do it for conversational speech or meeting speech. Then neural networks have ruled the various fields of natural language processing and other fields. And the first deep network was introduced in around 2011 to ASR, and then over more data and better methods, they reached the human level. Now the human level is set at a somewhat higher rate, 6% of word error rate. But it is essentially possible to reach human level of word recognition. How about MT and its surpassing of humans? You have heard Tom Kosmy's talk yesterday, the overview. We are struggling across a number of languages, depending on the way how you evaluate it and depending on how good your original translators are. Sometimes you are on par with humans, sometimes the best systems are still below the humans, especially if you consider context. So the assessment, the direct assessment that was used and is still being used for into English translation these days. You evaluate on this single scale the quality of the translation. For translation from English into Czech, we have always used the source-based translations, or we've preferred source-based translation. In 2018, it happened for the first time that the transformer trained by my colleague Martin Popel was significantly better than the professional translation of that year. We, of course, knew the caveats, the problem, the risk there. And it's that humans have translated whole documents. MT was translating individual segments, and the evaluation was done on individual segments as well. So this alignment, the similarity between the system run and the evaluation is a big benefit for the evaluation. So this result was actually not telling us that we are better than humans. It was telling us that the conditions are better for the machine. When you are evaluating a sentence in isolation and this sentence was translated in isolation, you will like it better than if you take the sentence out of the context. So that's the message. But nevertheless, we did a re-evaluation of the data, a very detailed analysis of like document level or context level. It was blocks of 10 sentences in a row of the very same system. And it turned out that for this particular system and these particular reference translations, the machine was actually better. So it did different errors than the humans did, but it did fewer errors in adequacy. So this is the qubit system, and it's better in terms of adequacy. It is actually worse in terms of fluency than the humans. So this is our big success. It made it into Nature Communications as a paper. So this is the superhuman or on par with humans translation from English into Czech. And I mentioned that also ASR is or was superhuman. So on our team, we had KIT, Karlsruhe Institute of Technology, and they had this superhuman performance on low latency speech recognition. So this is actually something even harder, doing the recognition as the sound is coming in, and you want to be as quick as possible with that. So we have superhuman start. Let's just put that together. We will run our ASR and we will run our MT, and we'll have a great system that will translate into the many languages, into the 43 target languages that we are supposed to provide at the Congress. Well, it's not that easy. So you need to acquire the sound, and I'll have some slides on that. And you need to present the output. I'm not going to show the videos, but you can have a look later. That also has some implications. Okay, wrapping it, that should be easy. And then we figured out that ASR people return words, lowercase, and we need sentences. So we need to first find the boundaries of the sentences. And if you shift the boundaries, you get half of the second half of the previous sentence and the first half of the next sentence, and you put them together. The MT will do its best to combine the words into a fluent sentence, of course, with meaning totally shifted. So, correctly recognizing sentence boundaries is a critical component for a cascaded system. So that's why people are moving to the systems that do not need that component at all. But we, at the beginning of the project, we just realized doesn't quite fit. And then you actually need to put all these research institutes together. So there is a little bit of infrastructure. You need to send it to the system. So this is what was the overall architecture in the project. That's what the Parvoice company provided us with. The mediator is a server, and all the research institutes connect to this with their components. And then someone connects as a client, and this client says, I would like this sound stream actually, to be processed through some sequence of workers. So ASR segmentation into sentences, machine translation, and then presentation, which ships it for the users to the web. And the client then gets something like a dummy output, so a confirmation that every packet was translated and presented to the web. The good thing is that the mediator and the workers are connected constantly, so the connections remain over time, and only they are used when there is the stream put together. It's also good because all the research components can be located behind firewalls on clusters of the research institutes. It's the workers who actively connect to the mediator. So you're avoiding a lot of administration complications, but of course you will be suffering from some extra network lag, and you want to do this real time. Then you also need to talk to the people for the particular venue. So we have realized that they are asking us, like, how many notebooks will you need, and what Ethernet cable do you need where, and what sound channel. So this is the first setup for the Congress as we planned it. Then we realized that there will be 6 interpreters around, so we will actually need sound from 6 of these interpreters. So this is a more complicated schedule, how the whole system will look from the point of view of the venue organizer. And the whole complexity of the translation is hidden here in this one box, like this subtitling notebook that's doing all the clever part. This is just the wiring around. And we knew upfront that we will need some test events. So we promised to do 3 test events, 2 before the Congress, then the Congress. So these are the bold-faced things, but we knew that this would not be enough. So we have started already in the first month of the project. In the 3rd month of the project, we had been testing the technology at student film fairs. So that's high school students who present mock companies, and we were trying the existing technology of KIT and Per Voice there. Then there were mock conferences of interpreters at the Faculty of Arts of Charles University. Then these events that the Supreme Audit Office of the Czech Republic has organized have come. And we had other open doors days, Best of Prague. I lectured that I also wanted to demonstrate live what the system is doing and so on. So that was the plan, and we were learning through experience, testing technology at each of these events. Then the COVID pandemic came, so lots of them were were canceled suddenly. So we had to change our plans. So then some months later, we had a demo for the project officer. So you have learned how to connect things to the hardware, and then suddenly everything goes remote. That means that you need to learn again how to get the correct now virtual wires. So there was this South teleconference instead, and then there was the theater debate. That's one of the demos that I'll just leave for you as a homework to play. Then student film fairs also had a remote edition, and the main event actually went hybrid. So the presenters, the key presenters were in person, and interpreters were in person, but that was much smaller group than original plan. So so the main South event happened a year later than it was actually originally expected. And yeah, so now what we have learned throughout this timeline, everything can fail, absolutely everything. So along this pipeline, yes, I already mentioned, we have the institute connected separately. So if the ASR is happening in Karlsruhe and the translation in Edinburgh are real time, and there is any network jam, then yes, your latency will grow horribly. So yes, it did happen that we had like issues at one of the partners. One of my demos, the Best of Prague AI demo, failed. I tested everything in the very room. It was, I will say it aloud, it was a Microsoft venue in Prague. They didn't allow me to connect wired because they said it's too complicated. I asked for that 2 weeks beforehand, but they still didn't allow it. And they said the Wi-Fi will handle it. I went there twice, I tested it, it worked with the Wi-Fi. And then the audience came. And the audience had their cell phones with Wi-Fi. They were not allowed to connect to the network, but all of the cell phones were still trying. And for that reason, I couldn't ship a single packet. So it was like shipping just a little bit of the sound, and then I was like the network was overloaded. So the demo failed because of the audience. We also had events where everything worked on our side, but the audience couldn't read it at all because the web events were like queuing somewhere in the presentation worker. So they just couldn't see it. Like the presentation server was overloaded at one point. The pipeline is complicated. One of my colleagues at one of the test events somehow misconfigured it, and we intentionally were doing the ASR locally on the machine so that we do not ship the sound. But due to the setup, he was actually accidentally shipping it twice. He didn't, nobody used that sound, but he was still shipping it upstream, and that also killed one of the demos. Then when we were doing the demo for the project officer, there was a suspect bomb excavated in Karlsruhe, and for 2 weeks it was impossible to go to the service room where something crashed for Karlsruhe, and they just couldn't, or maybe it was not 2 weeks, but we postponed the demo for 2 weeks because it was for a number of days they couldn't restart the machine, and we couldn't get access to the worker. And then I was supposed to give a demo for a NATO conference in Prague. And my main notebook, which I went to the venue twice to test it. I asked for the wire. They gave me the wire. The wire didn't work. They fixed it. I tested again. So I knew the wire would work. I came there for the presentation. The Dell notebook, when I opened it, said, "Oh, sorry, I'm low on battery. I'm going to start this Windows safe mode for you." Windows has overwritten the grub, and I couldn't access my Linux. So that's why I'm not giving a live demo today. Yeah, so these are all errors that you simply cannot prevent. The only solution is you have two notebooks, you have two wired connections and things like that. But on top of the unpreventable errors, there are still errors which you can prevent. So this is one of the errors that we have prevented in our setups. The problem here is that the speaker used the chest microphone. He put it to one of the sides of his shirt, and then he was talking in the other direction because that was where the whiteboard stand. So the microphone was catching it from the wrong direction, and that decreased the sound quality beyond the level accepted by the models. Of course, you can trade the models to some robustness to poor inputs. But if you don't expect this type of error, you don't do that. So, and your models are not ready for that. We have done a very small test. This is just 3.5 minutes overall. But on these 3.5 minutes for English ASR and Czech ASR, you lose about 3 or more word error rate points just by using the chest microphone compared to the head microphone. So it's really important, and that's what Matthias keeps telling to all the speakers here, that the microphone is properly located. So there are tips for singers. You must not hold the microphone this way, and you must not put it too close to your mouth, and you must not too far it from your mouth, and you must not stand in front of the speakers. So if I do anything bad, then suddenly all the interpreters and machines will complain. So it is very important that you check the whole setup and you keep checking it all the time. We also, when we were working with the interpreters at their mock conferences, this is like professional microphones for interpreters. So they play one sound stream to the left ear and another sound stream to the right ear. So they kind of abuse the connectors on the jack plug. And for that reason, when we wanted to acquire sound from that, we had to halfway connect the jack so that we could get the context right. So it didn't work when he plugged that fully, but when he plugged it halfway, we were able to record the data. So that, yeah, this is all that you learn live. Yeah. So there's another thing. The volume is absolutely critical. Of course, if the sound is too quiet, you will not understand. If the automatic capping or clipping, if the sound is too loud, some of the components will limit the too loud part of the sound, and they will severely damage the signal. So the clipping is actually much worse than too quiet signal for the recognition. So there is a number of volume controls on the way. You have the wireless microphone with some output, or you have the sound card. It has like 2 buttons, so that's 4 settings, and then a knob to tune. So you really have to fiddle with this, and you have to follow the pipeline of the sound so that in your ear you hear it well. You need to do this as the speaker is moving, because if I move my mouth closer to the microphone, then suddenly it horribly changes the acoustics, and some of the automatic systems will try to compensate for that, and you need to compensate against. So it's really something that has to be monitored live. And if your person who is monitoring live is unable to hear the difference between a clipped sound and a correct sound, then you cannot possibly cater for the event. So yeah. Do not listen to loud music. That's the message. Okay, so now ASR challenges. This is an example from the mock conference, or the conference of mock businesses of high school students. The speaker has some intention. The speaker wants to say something. The speaker wants to say, you have a bottle? Oh yes, we are situated in heart of České Budějovice. This is a non-native speaker of Czech. He's pretending to have a company with a bottle and to accommodate people on the river. There is grammatical error and there is, of course, pronunciation errors. So what the speaker actually says is, you have a bottle? Oh, yes, we are situated in heart of České Budějovice. So maybe my accent is already bad enough for this illustration on its own. And there is also background noise on top of that. So if you are a person listening to this damaged sound, you will hear something like, you have a bottle? Oh, yes, we are situated in heart of some city, and you would not know České Budějovice, right? If you use the standard noise sensitive ASR, you will get something like, oh yes, the off. And if you use some noise resistant ASR, because there was also some background noise, this was a fair kind of setting. So there was a lot of noise coming from around, and they were giving the pitch with a close microphone close to mouth, but still there was a lot of background noise. So the noise resistant ASR would recognize something like, you have somebody too? Oh yes, we are situated in heart, which is can we do? So there was the České Budějovice. It doesn't know the named entity at all. If you are a knowledgeable person or perfect ASR of the future, you would recognize it as it was planned. Yeah. So the reality check on the third month of the project told us that human error level is 4 to 6% of word error rate, and reportedly best neural networks are there as well. But we had these 90-second pitches from high school students, and the average word error rate of our partner, the best system actually available, was 40 to 50%, 10 times higher than expected. And Google ASR, for example, and Edinburgh ASR had 80 to 90% of word error rate. So actually these systems, the ASR of Google, often gives up. If it's this noisy, they just don't give you anything. So we had the best system available, but still it was 10 times worse than what is in the paper. So here is an example of the manual transcription, and then the Google, Edinburgh, and the KIT ASR. And this is actually the best recognized segment from the collection of these pitches, right? So there is lots of errors, and you are going to translate this. So I don't have any illustration of that, but if you misrecognize a word and you are reading it in the original language, you as a human can somehow realize, oh, this is a misrecognized word, heart versus heart. That's possible. But if it's translated to any language, like the Czech or whatever is your mother tongue, heart and heart would be totally different words. And it's very difficult to recover from the translation error, which multiplies the ASR error. So there is the issue of segmentation, and there is this multiplication of like lexical diversion. Yeah. So one of the problems, a critical one, is the custom terminology or names. So later in the project, Christian Huber has introduced a memory component so that on the fly we could fit in the lexical items that were not known to the system at the training time at all. So, for example, the eliter is not something generally available in the speech data sets, but if we lowercase it so that it is compatible with the way ASR people work, and then we break it into the subword units that ASR people use, L, E, or whatever, and then we assign it to these indexes in their existing lexicon of the ASR system, then we can add one more part to the ASR model, and the part contains these items statically, and the attention is modified so that it can attend not to the source, but rather to these items by checking the similarity with the source at the sound snippet level, so to say. So so this memory worker, and this memory can be modified at runtime. So the system is running, and you are adding and removing entries from the memory, and by that you're allowing the standard encoder decoder system to suddenly decode something which was never seen in the training data. So this is a clever trick, and we use that, of course. There is an evaluation which we did, and it's on archive. So the evaluation is based on 10 EMNLP talks from 2 years ago. We populate the memory with the terms as needed by the transcription, and depending on where they are available. So of course, if you know what the speaker will be exactly saying, you can use the transcript and populate the transcript, populate the memory with the words that are not in the transcript. And you can do this in general, like upfront before the whole talk, or you can do it at the occurrences of the word. So when the word is first occurring, then you can simulate the behavior of an operator. So the operator is watching the system output. Then someone says a liter. The system recognizes something crazy. The operator says, "Oh, this is a liter," and enters the word to the memory. So all the next occurrences of a liter would be recognized well. So this is if the memory is extended after the first occurrence. If there is some delay in the system, maybe the operator can fix even the first occurrence by kind of hiding the wrong hypothesis and shipping only the corrected one. So this is if you actually populate it before the first occurrence. So this is the two setups, and having the transcript is not quite realistic condition. So what you often have is the slides. So you can add words which are needed for the current and neighboring slides, or all slides, or you can add the words which are appearing in the whole paper and the slides. If you do not have anything in the memory, then you are unable to recognize the words. You are just about 10% of F score of recognizing the words, because they happen to be composed of parts that you knew, but that's very rare. If you are adding the word from the transcript and adding it as if you knew that it was going to be said in the next segment, which is the oracle before it appears, you can get up to 70% of F score, so combination of precision and recall on these words, and it is somewhat worse for other conditions. With the realistic conditions where you are adding the words from the paper or from the slides, you are at around 0.6 level, and here the evaluation depends on the fact whether these needed words needed from the transcripts actually are or are not available in the slides. So if they are not, then it's kind of unfair condition. So this is the lower scores. If it's the fair evaluation where you are expecting the system only to identify words which are available, then this is the 0.6 scores. So that's how it works in simulation. And I also put it to use in practice. So this was this year's 2022 Meta Forum. If you want to do some hot fixes, if you want to do live post editing in VI, talk to me. I use the VI editor for the rolling stream. This is like my user interface for the setup. So I see what is being recognized. This is all rolling, and this is being shipped. And I have a little window of that rolling content, and whenever I hit a button, I get an updated view of this window. So of course, I must be editing something which is stable. So I have to manually ask for a new update. So I ask for a new update, and here I see what is the current recognition in the window. Someone has said some name that is clear, because if you look at the continuous updates of the outputs, you see things like my name is Siri, just the microservices. And then later on, it has recognized the same sound as my name is Siri, just the Bulgarian Python. And and then later on, the same sound was recognized as my name is Billary. I come from University of Dallas. And then the same thing, my name is I come from municipal data. So the misrecognized names here are actually the names which I put into the memory upfront. They were supposed to happen during the day. But because the memory is so preferred over the general model, then these names often create false positives, and like you often pick up the items from the memory even when they are not supposed to be there. So and then the third one was this Pilareo. So in my live editing, I clicked that with the mouse, VI with the mouse support. I clicked F1 and I edit a rule. Don't do this. This is a bad name. So actually, in this case, if you know that you cannot recognize the name, the best action is to delete it. And the same thing happens for some bad words. So I have some small letters, bad words here that I also spotted, and I just deleted them. Yeah. So this is what I did. I injected a rule which said delete these words. And I had to do it live because I would not be able to list them up front. It would be deleting too many words or deleting too many names. This is where I'm typing the rule. So this is actually just a misrecognized thing. It was Philips, the company, but it was recognizing Philippines instead. So I inserted the rule that whenever someone says Philippines, it should actually emit Philips. Of course, when the Philips presentation is over and someone from the Philippines comes, you have to retract the rule. Yeah, so this is what is happening later on. You see that these rules are applied here. And again, I can click then and say, remove the rule. So for the next occurrence, this is what you have to do. So this is ELG, another rule that was like valid throughout the day. The same situation is with Joachim's. There's different spellings of Joachim's with K or CH. So if you want to be nice to the person, you would spell their name correctly. So you need to disambiguate which Joachim is that, and based on that, you should fix the memory or fix the rule. So there is a lot of subtleties. Finally, let's assume that we have arrived at some transcript. Let's move on to the translation task. Yeah. So just as a reminder, in Eliter, we promised that we will cover all Eurosci languages, primarily in the setup, going from the speech recognition of English, German, French, Spanish, Italian, Russian, and Czech into all the 43 target languages. This calls for multilingual modals. I'll have some slides on that later on. But first on the quality, I said that we have this superhuman English to Czech machine translation system. These were auditors. So we also evaluated the quality of their typical texts. So this is now machine translation on its own, no speech. This is audit reports translated with the MT system that was very good on news. The auditors are not experts in language technologies. The easiest scale that we could use with them was the GCSE style of scoring of essays. So they have evaluated the MT outputs on language resources, spelling and morphology, on vocabulary in two ways: adequacy of terms and clarity of the text, syntax and word order, and overall coherence and understanding of the text. And they have evaluated in a blind way the reference translation, something they themselves created several years ago. So it was probably the same group of experts, but many years ago, like 5 years ago, they have synchronized and translated, corrected the documents that some professional translation did for them. They manually reviewed that. And then 5 years after that, we were showing these side by side, or well, not side by side. They had access to everything, but they were judging independently each of them and not knowing which is which. Our best systems, some worst systems, and the reference. So it turns out that in all the levels, the scores were like on par, and in language resources, spelling and morphology, the best system was actually even significantly better. So this confirms that evaluated overall for the text quality, the system worked even for audit reports. At the same time, they did complain about terminology in the finest sense. So these are experts of some field, taxation. And in Czech, if you say, and I don't know the terms, I forgot the terms, but there's two ways of saying the tax on something, like the income tax or the tax on income. These two formulations would mean slightly different things. One of them is the term, and one of them is just some layman's wording. So they complained about these subtleties. The message is, if you are evaluating any specific narrow domain, you need to have it evaluated by the specific experts in that field. The crowd evaluation that WMT uses will never work for any domain, any specific domain. because the annotators that you will get will be just random people. So they will not be expert. We are so close to the human quality that you need very good evaluators. If the evaluators are judging just by like the general knowledge, they will often confirm even something which is not a good translation. But there is a more important error that we have spotted. This is a similar thing. This is my translation of a Czech sublease agreement into English, so non-professional translation into English, which I'm back translating by that very good system into Czech. I'm not expecting you to read the English legalese of mine, which is wrong in many ways, probably. Supplement number 1, whatever it's the sublease of the apartment, it reads as legalese. Here is Czech. In Czech, dodatek číslo 1 ke smlouvě o podnájmu bytu of some day, some names. It all looks good. Czech legalese. Yeah. If you read it carefully, you will realize that there are two parties of the sublease: the lessee and the tenant and the lessee. The machine translation system decides to use the same word for both of the parties. So the contract says that the tenant and the tenant will be responsible for this and that. So it makes the document totally unusable. So it's all the names are good. It's just the terms that make it totally useless. So talk to Kirill if you haven't seen the poster on terminology test suite yesterday. Talk to Kirill. There will be probably a terminology task next year as well. So this is one thing to focus on in machine translation. Then we are doing machine translation into many languages and from many languages. We will be building some multilingual systems, but not all with all. We have English-centric setup. So we are pivoting through English, and there is an inherent issue when you're pivoting. Here's an example. The colleagues of mine have put together a system which translates from Ukrainian into Czech. So before they did it, you could use Google Translate to translate from Ukrainian into Czech. The problem is that Google goes via English. So in English, the word application is ambiguous. Is this a cell phone application, or is it an application for some support or whatever? This word is not ambiguous, or the words are different and equally different in Czech and Ukrainian. So if you would be translating directly, you would not screw it up. But if you are translating with English, you will change the application for support into and the application for cell phone. So that's the problem. Here is the reference to the Charles translator. It was created by my colleagues just in 2 weeks, starting at the beginning of March this year. And they go directly, so they translate it correctly. There is another subtlety, and that is the user, taking care of the user. So who is going to use this system? This system is going to be used by Ukrainians who cannot speak Czech, and maybe they cannot even read Latin script with confidence. So for them, we provide the Cyrillic transcription, which, if they read it, would sound similar to the Czech. So they could use this also in speech communication. This is different from Google. In Google, you paste the Ukrainian thing, and you see that transcribed to Latin so that we can understand what we are entering in. But if it's used by Ukrainians, they would not know how to read this target. So, well, Cyrillic to me is still readable. I don't know about you, but if it would be Arabic script or one of the Indic scripts, then I would be totally screwed. And Google is putting the transcription to the wrong side, so to say. This is like the ignorance of the user. So you have to always think about the user and how the result will be used. Here is another example. People would be tempted to say that this is a gender bias, but this is actually a translation error because you are pivoting. So the input is a stupid teacher male and a clever teacher female at our school. And the translation by Google says it's clever teacher male and stupid teacher female. That's because the English loses the gender, and then the bias is applied. So if you didn't lose the gender, you would not face the bias issue. But since you are pivoting, you have lost it. Same thing by DeepL, but going directly, it just follows, it observes the origin gender. Okay, so multilinguality. We are targeting many target languages at once. That's multi-target. And here we only focus on efficiency. So we want to translate into 43 languages in one go. The sound is coming relatively slowly for the machine translation. So we have plenty of time, but we use GPU batches to translate into many languages at once. So this is the efficiency that we benefit from. And multi-source, this has been known for years. If someone has already translated something, they have probably resolved some of the ambiguities. So if you're translating from German Schloss to French, you would benefit from knowing if this Schloss is a castle or if it's a lock. So the source word is ambiguous, but the second language translation of the source word resolves this ambiguity. So if you have access to the two sources, you can translate better. There is one caveat on multilinguality, especially the high multilinguality that we had in Eliter. We don't speak 43 languages. So for all the languages, except for the few we speak, we have to rely on automatic measures. And we just don't know if they're doing a good job. Actually, we do know that they are not doing a good job. So, we had things like we were shipping Russian instead of Ukrainian because we didn't know that there are differences, and the data set was cleaned in order to avoid Russian, but still lots of Russian appears genuinely in Ukrainian text because of citations, for example, or film names. So there is a lot of it's not code switching; it's just citations. They can read it, they use it, but it was enough to damage that. Then we only after the first live event we realized that Serbian can be written in two scripts, Latin and Cyrillic, and our system mixes these two because the data is in Cyrillic in both. So half of the sentence was in Cyrillic and the other half was in Latin because it just happened to translate like that. So then with Norwegian, there are two versions of Norwegian we again didn't know, and the automatic measures, if the test set are also tainted, they would not tell you. So that's a big thing. I'm not going to all the details. I just want to advertise the book that we have written with my colleagues, and you can access it online. There are challenges and a lot of wishful thinking in multilingual research. So we are trying to avoid the wishful thinking. We are trying to warn about all misconceptions. And there is one that I would like to highlight. So it's on massive models. So Google had a series of papers and a blog post, how they are putting all the languages into the one model, and they are seeing great benefits for the low resource languages. So this is high resource languages and this is low resource languages. It's all something into English. It's 102 source languages. And the different lines are as they are increasing the modal capacity. So what Google would like to have would be one modal, so that they would care for just one modal and they would translate into all the languages. And it would be beneficial for the many low resource languages, but this model would harm the half of the high resource the half of the higher resource languages. So they are trying to increase the model size so that the bigger languages fit in as well. And they are getting just above the baseline of bilingual translation with 6 billion parameters. And then they had a blog post about 50 billion parameter model. And with that, they are seeing 5+ bullet points increase, even in the high resource languages. So that looks great. But I claim that they have used the wrong baseline. So the baseline is the bilingual translation limited to 375 million parameters for the language. So if you think about the overall modal capacity, and you have big languages and small languages, for the small languages, you benefit somehow from the big languages. Read our book to see benefiting from other scripts than the languages are written in. But for the high, if you then grow the model, it is very likely that the small languages will not need as much capacity as you are allocating to them. So there will be lots of leftover capacity in the model. And now the big languages can use this extra capacity. So the bilingual baseline should actually have access to this extra capacity. So an upper bound baseline would be indeed to use 50 billion parameters for the single pair. And then I'm pretty much sure then you would not see any benefit from the multilinguality. So this is a very subtle way of like again having the technology rule over you. So you kind of do not realize that the bigger languages have flown into the space which was originally reserved for the low resource languages. So that's one word of warning. Okay, so let's move to speech translation. This is the online ASR. The input is coming and growing. You see updates, so updates about sentence boundaries, updates about the words, and we want to translate this. So there are two major approaches: retranslation or streaming. In streaming, you're only emitting the words and never can go back. In retranslation, you translate each sentence as you get a new update. The benefit of retranslation is that you can just use your empty tool and there will be some flicker on the user's screen. There is lots of work on this. Chantal has presented a nice paper yesterday. So yeah, just follow the references. There are three qualities to speech translation. I've already mentioned flicker. That is how much is the output being changed for the user. The latency is how late are you compared to the individual words that were said. But of course, you have to wait for the German verb at the end of the sentence. So some latency is kind of inherent and given by the language pair. And then there is the ultimate quality once the whole sentences are stable. We have within Eliter, we have developed this SLTF. This is the wannabe Zuckerblef for speech. It comes with a nice Eliter test set. So if you're doing anything, please try this out. You will run into some technical issues, file issues. Contact us and help with that. It needs your support now, but the test set is definitely nice, and the tool has all these aspects of evaluation. And also speaking about retranslation and streaming. This brings the trade-off between flicker and delay. So if you are retranslating, you can afford to ship some partial or imperfect hypothesis because you know that you will fix that later. If you are doing streaming, you really have to be sure about the word. You cannot go back. So streaming demands that you are stable about your hypothesis. And David's paper yesterday mentioned that different people, depending on their knowledge of the source language, have slightly different preferences with respect to delay versus flicker. So that's why we still believe in the retranslation approach, because it has the room for being more simultaneous. This is the setup that we used in the end in Eliter. Retranslation approach still cascaded for the production. We had experiments with end-to-end speech translation as well. Look at our deliverables if you want to know the details. It was multilingual model. We simply mixed in all the languages. There are papers that you should not mix too many. So we had 42 languages on the target side in one of the setups, but it's actually better to use 5 and not more. Then there are some tricks like stabilizing the retranslating approach through self-training, and then there is a very good combination of pre-trained WAF2VEC and MBART and a neural segmenter at IWSLT. So there is a way to stabilize even the retranslation approach. That's another thing. Look at all the details. Let me talk about the interpreters in the loop now. So this is the reality of a multilingual event. There is a speaker speaking, for example, English. There is interpreters booth. They are interpreting, for example, into German. And you have a participant who would like to read Czech. So what do? You do not have the funds to hire another interpreter. You would like to use some technology. And then when you're developing speech translation technology, you can either translate from the English source, which is faster, or you can translate from the interpreter, which is in German, so you need a different ASR, but there is the delay, but there is some interpretation, some benefit of that. So what is the benefit of following interpreters? First of all, the conditions for speech and sound are much better for the interpreters. They are in their separate booths, sound isolated, and they know how to behave to microphones. So they are filtering out many of the wrong effects. They also are trained to make the message clear. So they are much better at articulating things. And even though our segmenter did not follow the non-word, the paralinguistic patterns, the pronunciation style or the intonation, we didn't follow that. We only followed the string of the words. Still, it was much easier to segment the interpreter's speech than the original speech. So spontaneous speech, as the one that I'm presenting now, is very difficult to chop into sentences. I just don't speak in sentences. But if the interpreter is trained to produce clear-cut messages, then it will be clear-cut also for the system. So the segmentation is halfway resolved. And there is this cultural independence. The interpreter is aiming his message on the target language audience. So, for example, here in the example, it was the German audience. But still it neutralizes some of the English specifics in the message. And this neutralization will be beneficial even for the final end user in the Czech language. So here's an example. We have the original speech in English and the interpreter transcribed and then the gloss of the interpretation. You see that it is much shorter. Part of simplification happens here, but it is typically the good simplification. So interpreters know what to drop and what not, so they know how to do this, and it is articulated. So we have two sentences in the interpreter's speech, whereas we have one huge blob in the original speech. And we also have something which is called functional generalization. So the original speaker was talking about comparing Vienna to Halvang, and for Czech listener, it is not important where Halvang is. It's just some small village. So the functional generalization of omitting that particular name is helpful both for our ASR. It would not need to know Halvang, how to recognize that, and also for the final final listener, because they also would not know the Halvang and they would have to make the inference that Halvang is some random small village. So the interpreter does the interpretation for the user and also for our systems. So here is an example. Later I'll provide a link to the two videos. So this is the theater debate. So my other colleagues have trained, well, actually they have fine-tuned, I don't know the details, but they have fine-tuned GPT-2 to generate a theater play. And they did it in collaboration with the Shvanda Theater in Prague. And indeed, this play is still taking place. The derniere will be in January or in March next year. So it's really played on theater, fully generated by GPT. Only 10% of manual interventions to that play. And after this hour-long play, there is always a debate, a panel of discussion, which explains to the audience how much of the cleverness and impression is actually added by the actors a lot. So this debate is what we were also testing our translation on. And it was in the COVID times. And this debate was with far distance microphones, and the people came with their face masks. So if we were following this Czech live debate with face masks and far microphones, then we would not recognize anything, even though our ASR quality of Czech is pretty good. Luckily, we had the interpreter sitting in a different room, and the interpreter was simplifying the sentences and giving us much better conditions. So it totally saved our performance. Yeah, so I'll talk about WSLT. There is the simultaneous translation task, and this year, 2022, we added humans to WSLT, and we added humans in two ways. one way was to provide benchmark on interpreting. So the same sound inputs were also interpreted by a professional interpreter. And another way was discussed yesterday by David Jaworski. We evaluated manually the outputs. The test set of IWSLT has some common part, which is TED Talks, and some non-native part, and that's the very hard domain that I mentioned. It includes the high school students in a noisy environment. Yesterday, David mentioned that his scoring, the continuous rating, correlates well with Blaise score. This is it. The person correlations are close to 0.9 or even 0.93 for the non-native part. If you mix the non-native and the TED Talks together, then the correlation somewhat decreases. Is 0.85, but it's pretty good. This plot is available in the second version, in the updated version of the findings of IWSLT. Here is a human evaluation of the systems and the human interpreter. So what we did with the interpreter was to manually transcribe it, time align it according to when it was uttered by the interpreter, and it was presented as subtitles in the same form as the system outputs were presented. So it was comparable. We did a shift. We did that both for the systems and the interpreter, so that there was not a realistic lag. It was more synchronous, so that the evaluator would have so that we would be saving the memory of the evaluator, so they could be immediately judging what they are hearing with what they are seeing. It was bilingual evaluation, listening to the source speech and reading the subtitles in the target language. And this is the average scores. So the higher, the better. In the various conditions, we have the TED Talks test set, the common and the non-native test sets. The best system was the Charles University and Karlsruhe Institute of Technology set up the WAF2VEC and MBART put together and onlineized so that they would run in low latency. The actual computational efficiency is bad because the implementation is slow, but in theory, the theoretical performance is good, and the latency is low. And this manual score suggests that on the TED Talks, the best systems are in the low latency are actually better than the interpretation. We don't have any latency of the interpreter. We just haven't measured that yet. We could have also put the interpreting into one of these columns, whether the interpreter is low or medium latency. I guess they are medium latency. On average, interpreters are 4 seconds behind the speech, but there are cases where the words that they utter relayed back, translate words which were said 20 seconds or more, half a minute ago. They have this long span, so they simply, if they do not have the capacity to say a message at one point, they will wait, and they are happy to say that half a minute later. So that is a hard alignment issue. Human interpretation seems to be beaten on TED Talks and is clearly still better on the harder conditions of the non-native speech. So I would be very careful to speak about surpassing human interpreters because there are all the subtleties of the evaluation, all the kind of preparation. So I forgot the details. I think that we didn't tell the interpreter anything about the topics, and that's not fair. So normally the interpreters get a lot of preparation time. They get all these slides or whatever. So if we gave them, maybe we gave them like the idea that this TED Talk would be on icebergs, and that was it, right? And then there would be some mock presentations of companies. I don't know if we told the interpreters what companies would be presented. Probably not even that. So it was very hard for the interpreters. So yeah, we need to do better. So here is a comparison of the interpreting into German and of the high latency Charles University Karlsruhe Institute of Technology system. And this is the source. And the alignment is my manual alignment. it is very rough at the level of paragraphs. So I inserted the paragraph boundaries so that it roughly corresponds. But there is a direct correspondence only with the system, of course. So the system preserves the sentences, whereas the interpreter is totally shuffling the things. It is interpretation into German, so that's why it comes out longer. Often it comes out actually shorter. German speakers would explain why it has to be longer in German. But then I illustrate with the, so here is the color coding if you would be exploring the slides on your own. The soft colors backgrounds indicate spans which correspond to each other. So the beginning is fine, but then the interpreter has mixed into one sentence what has been put into two separate sentences by the original tool. Then there was some reordering with this big data tool. Then there was a lot of not quite parallel content. It is difficult to align and so on. So you see that the alignment will get much harder. And I also color code some of the issues. So for example, the interpreter has made the error of translating 20,000 as 10,000. So the numbers are hard. Then another error by the interpreter was that they translated gray into green. Then another thing is what should be done. The original speaker was presenting some slides, and the slides were in German. The interpreter was also translating into German. The original speaker has apologized. Sorry, the explanations are still in German. Of course, this message should not be said in the German interpretation because there is no need to apologize. Actually, you are happy that the slides are in your language. Right? So this is something that die Erklärungen sind immer noch auf Deutsch. The system has translated it. It's not harmful, but it's not needed. And the system also then fabulated some horrible thing. Oh, when it said something like, "Oh, I'm sorry that I have done that." So it has fabulated a message which comes after this probably common apology, right? And then instead, the interpreter has said something different, and it was probably wrong as I labeled that. And then there is 3.2% total amount. There is something about this horrible number. And I'm not sure if the number it's probably correct, but it's just difficult to judge if you don't have the proper tools for that language. So the named entities and especially numbers and like names of shapes or whatever can be often swapped by the interpreters because they are overloaded in this aspect. The empty system has made the error of translating Austria into Australia. A common mistake, and then some other translation error. But otherwise, it was good about the big data tool. It was actually more knowledgeable about the content than the original interpreter. And it was good about the number and good about the color, but then it injected some hallucination. So I can see why they are on par, but they are not directly comparable. Yeah, so multi-source speech translation. So this is the picture. We have the source, we have the interpreting. Why should we follow just one? So what we did in Eliter, we decided to follow all. So we have the original English speech. There is the German interpreter interpreting into German. We do have English ASR and German ASR, and we can easily translate live on the fly the German to English And then this is what I was doing. I'm afraid I don't have a screenshot. I have a video of that you can look at later, where I was looking at 5 versions of English, all rolling. One of the Englishes was the original transcription, and other Englishes were coming from the ASRs and translations from the interpreters. And I was manually choosing which of the Englishes is the best one at the moment. So if you want to know the details, it's our workshop paper at ASR in real world conditions. I was there were good reasons to choose among the sources, because some of the interpreters had bad accents, or sometimes the original speaker had the bad accent. Sometimes some of the modals crashed, so some of the sources were not available at the moment, and I had to switch to another source. So we have an automated system which works with just the resiliency. We know upfront which streams we trust in some particular order, but if these streams become unavailable, we switch to the existing stream to follow the fallback solution. So when I was doing this manually, I was also just by eyeballing, judging the quality, and then choosing which of the Englishes should be the source for the moment. And then we had the English to many, English to 42 translation model, so that we were able to present 43 languages in the web interface. But as said, there was also the French speaker, the Czech speaker, and so on. So this is the multiple versions of the source that I was following. The demo contains sounds in multiple languages, English, French, German. That was a closed session, so we couldn't give you the demo of this. This is some Europal session, and the original speaker was speaking in Bulgarian. So that's another reason why you would like to have the chance to follow interpreters, because if you don't have ASR for the source language, you can at least provide the service based on other languages. Yeah. So what is Dominic, my PhD student, working on now is to combine both source and interpreter, not just switch. We would like to benefit from the interpreter and do multi-source speech translation. So there are some benefits: the disambiguation and the overall better ASR of the interpreters, but also the fact that the ASR errors will be complementary across the different sources. So if you don't understand something in German, you can understand it because of noise or whatever. You can understand the same message from the French interpreter. So you should be able to recover from that. That's great. And if you would have this automatic merging, we would not need to manually switch between the sources. It is possibly better than either of the options, because the source, if you are translating speech from source, the translation will be word for word more faithful, but often too complex to perceive and too fast to read. The interpreters are shortening the message on purpose, so that's the benefit of their output. So it's briefer, simpler. There is some intercultural transfer happening, but sometimes it can be too slow, and sometimes we don't know if it's fully reliable. And we know little about what the target users actually need, aside from what David said yesterday, that if the speakers know, if the audience knows the source language somewhat, they prefer simultaneity over quality or over Flickr. So there's also a chance or a risk that there will be no improvement in practice. Maybe one of the sources will be good enough all the time, and maybe even with more sources, none of them will be good enough never. So that in various settings, this may be of no use in the end. So I'm slowly moving towards the end. Maybe there will be some questions some time for your questions. That's good. I've mentioned various demos. The demos mentioned in this talk are available on this link. You will get the slides later, so you can look at the demos. There is sometimes two file formats in case the MKV does not play well for you, and it's also much bigger. So that's one option. The multilingual translation, the one with the Bulgarian, as I said, this one has multiple sounds, so you can listen to different languages. Unfortunately, the delay is no longer true to the original setting. So that's just a word of warning that the demo was prepared with not exact alignment of the time tracks. So that's the demos. And then on our Eliter webpage and elsewhere, we have several blog posts on what we did, and some demo videos as well. Some of them are the same ones that I'm shipping with this talk. And we have a popularization of speech language translation in the conference setting on YouTube. Yeah, talking parrots. I didn't want to miss this topic. So large pre-trained models rule empty and empty metrics and quality estimation and other tasks. You have seen talking parrots throughout the conference. I don't see anything bad about it, but we need to be aware that we are trusting more the crowd of parrots than the source. And that's what we really have to carefully think about. Do we want to put more weight into the source or into some general knowledge? In our case, we are deciding whether we put the trust more into machines or the interpreters in the multi-source interpretation. So, for example, interpreters have told me this situation. Someone was speaking in Romanian, and so the interpreter was Romanian, translating into his second language English, and his Romanian accent makes 17 sound exactly as 70. Then if you are following and you are interpreting further, which interpreters do, the relay interpreting, that's a common thing to do. You need to use your common sense knowledge and correct that and translate that further 17 as 17, not as 70. A language model such as BERT would probably know what is the population of Romania, and they would probably correct it, maybe even like approximating the numbers if it was not said exactly. But do we want to trust more the general knowledge, or do we want to trust what we hear in the source? And what if the speaker says this in a what if sentence? What if Romania had 70 million people? What would the general knowledge model do with that? This to me boils down to very general questions, to a very general thing. We need to decide answers to which questions should be obtained by voting. These parrots are voting. It's our data sets who are voting, whether teachers are stupid or clever, male teachers and female teachers. Do we want this information to be decided democratically, or do we want to rely on some trustworthy source? So this is the hardest part. Throughout our experience in Eliter, we have had the many failures. You have seen all of them, but we also have some tips on improving the perceived quality. So if you're blogging, you know how to improve the perception. So if you want to present speech translation system live, it is very helpful to have natural delays such as music in the input stream. This is the time where your system can clear all the buffers, ship all the outstanding sentences. The audience is listening into the beautiful music, and they are accepting errors lightly. One of the demos is like that. It has music, slow speech. That's perfect. So use speakers who speak at a comforting pace. That's also helpful. Interpreting my speech would be horrible, and I'm really sorry for the sign language interpreters throughout the last 90 minutes. You should grab the sound at the very source and ship your output separately, independently of the streaming. So today, everything is hybrid, everything is streamed. If you stream with YouTube normal latency, you're getting 15 to 60 seconds. You can do anything in those. You can really post it all the outputs you like. And if you go ultra low, it's still 2 to 5 seconds, and you're shipping only text. So shipping text is much easier. So then actually what in many of those sessions, as we went hybrid, we were really shipping the subtitles and the stream separately. And we were showing the text before it was available to the audience. So we were causing the confusion in the other direction. We were predicting what the people are going to say. Yeah. Then it's very helpful to make sure that the user doesn't need your service. So in our case, the Supreme Audit Office, of course, had their interpreters. And at one point, they considered not using them and relying on the technology. I'm happy that they were not this courageous. Yeah, so it's good if this complements the what people really need. And I've also figured out that it helps to make some or achieve some little of mental overload of the one who is assessing the quality. So if you are listening to a speech in your second language. So, for example, if I would be listening to an English or German speech, and I would be seeing live translation into my mother tongue, into Czech, I would be more focused on the thing that I'm listening. I would be more busy with understanding my second language. And I would have only like a little chance to peek at the keywords, to spot keywords in the outputs. And there are plenty of good keywords in the output. So if you want to impress with your speech translation system, present it in the second language, the sound in the second language of the beholder, and show them their mother tongue. They will be happily accepting many errors in their mother tongue. They will not see many of them, and they will actually be spotting good keywords. So this is one way of improving the perceived quality. Yeah, so I wanted to finish with the yet a harder task. So this harder task for sequence-to-sequence models is automatic summarization of meetings into minutes. So if you think that your sequence-to-sequence model is excellent at one-to-one sentence correspondence for machine translation, and if it handles well the interpreter plus the original speech misalignment, which is kind of paragraph level misalignment to one source, then go one step further. Summarize 45-minute long speeches into bulleted points of the minutes. So we call this Automin, the shared task. It will be the second instance of the shared task. We are providing training data, which was collected within the Eliter project. It's manually corrected transcripts of meetings. These were de-identified, so there are some like placeholders instead of people's names. And with these ASR transcripts, we are also providing manually created minutes. Because minuting is a difficult task for humans, the outputs will differ. So that's another challenge. Aside from automatically summarizing, you can also do our new task, evaluating the quality of these minutes. And there is an intermediate tasks. There are two intermediate tasks on matching whether this transcript matches to these minutes or different minutes, because there were some of the meetings which were kind of recurring project meetings over a number of months, and it's the same de-identified entities, but kind of same topics that keep recurring. So identifying which transcript corresponds to which minutes, it's not trivial. And also, if you have 2 minutes, saying whether they belong to the same transcript or not is a stepping stone towards the evaluation, but again, not a direct task again. So please have a look and do take part. I'm finishing. My last slide is here. I presented Eliter. It was a complex pipeline. We've learned and halfway resolved issues all along the way. We've introduced manual interventions at various stages to fix catastrophes. And then I was talking about multilingual machine translation and the caveats of that. Do have a look at the book. And then started relating interpreters and simultaneous speech translation. We're benefiting from interpreters because of their clean speech. In IWSLT, it turned out that in-domain automatic systems can be close to humans. In non-ideal conditions, there are many problems that we have to solve before we are at the level of interpreters. And we are aiming to benefit from the interpreters. And I was highlighting the question, which source is more trustworthy? Should I trust the original speaker or should I trust the interpreter? Because some of the errors are actually, some of the errors come in the source and the interpreter then fixes them. So in general, the final message is, if in whatever evaluation you are doing better than humans, then most likely you're doing something wrong, or you have asked a wrong human. So with that, I would conclude. Thank you.
Okay, thank you very much for a great talk. Questions at the very end.
Hi, thank you so much for an interesting talk. I was curious about respeaking.
Yeah.
So you're talking a lot about we are having interpreters. The interpreters have a clean sound booth. They can say maybe even the commas, periods, whatever, right? They can create a very, very clean
Yeah.
speech for you to transcribe and to translate.
Yeah.
Why don't we, if we have an English speaker, why don't we just do that with a clean English respeaking?
Yes.
Would that not just improve the?
Absolutely. This is what the commercial sector does. We just didn't promise that in the project. We benefited from interpreters doing respeaking on the go, kind of, also in a different language. I have only one comment to this, or two comments. Interpreters in their education these days are learning about respeaking as yet another activity they may be asked to do. So it's like new also in the in this area. It's like monolingual interpretation, if you or could be even monolingual interpretation if you wish, and you need to be trained for this somewhat as well. In one of these sessions, we also had a failed attempt to use the person in the loop, because it was an interpreter, but he was asked to do respeaking. And he was not knowledgeable about what to do exactly. So he was like interpreting to the same language, and he actually brought in a worse accent than the original speakers, and worse pronunciation. So he was like, I don't know the English term, stepping on his tongue. So pronouncing somewhat unclearly. And that made that input totally unusable. So yes, in practice, this is definitely the way to go.
Okay, cool. Thank you. Do you know what's the actual like difference would be than the real world disgusting speech to a proper respoken speech?
I don't know if I understand the question correctly.
Like
It
the
depends on
output from your system eventually is the translation to different languages. And if you have an English speaker and you take just the English source versus you would take an English respeaking, would that be better than taking interpreters for different languages? Or would that be on par with what your system does?
It's very likely language setting dependent. That's we had that topic. We explored this topic. This is actually, then you need a multi-source machine translation system, which combines the original speaker with the respeaker. You will have the asynchronicity that you need to compensate for the delay. This is something which we still have to resolve for the interpreters, but the solution will be the same for the respeakers. And then when you are able to align this and use the standard multi-source thing, this is what we explored in another project, Bergamot, and there the idea is that you are translating from paraphrases, and there are papers that benefit from paraphrases, even in the case when the paraphrases are automatic. So yes, using respeakers is definitely beneficial. Whether it is better to paraphrase through a different language or then multi-source from a different language will be dependent on the language pairs or languages.
Cool. Thank you so much. I'd love to keep talking about this more offline.
Thank you. Hi, Andre. Nice to see you in person. I saw your name on my collaborators.
Yep.
So I was from Adapt Center with collaboration with you there. Now I'm in Manchester NLP group. I wonder, do you have any source, if I missed it because I joined late, direct speech-to-speech translation or speech-to-text recognition, text-to-text translation, and text-to-speech synthesis? Do you know or your thought about their pro and cons of these two comparison? Because we were talking about this during our lunch as well.
So we on purpose stopped before producing speech. We emitted only the text as the output. That was the setup that we've asked for. One of the reasons is that the delivery is much easier, because then in the audience, people can select the text and they can just read it. Actually, reading the subtitles is another thing. I haven't discussed that brings a difficulty for the audience. So I didn't mention that. One of the failures that we also had was just poor presentation. If the font is too small, if it's too far, it's totally unusable. If it's if you project it on some handheld device, then people have issues with focusing to the slides and to the speaker. So so this text translation is easier for you as the developer of the system. We didn't have any speech people in the team, and it brings some complications, but also provides some benefits for the end user. But comparing the setups, whether you want to go via text or you do directly speech-to-speech translation. This is, and to me, I would say that this is an open research question. In the long term, direct speech-to-speech is definitely better because this is what humans are doing, and it will definitely have better options for all the named entities and things which never appear in the parallel data and never appear in the like transcribed speech data. So if a foreigner comes to Prague and I say Prague city or street names, then I speaking English, I will somehow adapt the names, or I will say them as they are pronounced in the native language, and it will be understandable. But if I go via text, I'm bound to screw them up.
Okay,
So
like
that's a clear benefit right away. But otherwise, of course, you have the non-parallelism and the need of like parallel spoken data. So dubbed films are definitely good. It's very close to dubbing in some way, but dubbing has the further constraints.
Okay, thanks for the thought.
There no further questions?
So the first time I got encountered interpreting was, I think, the EU Bridge project, where we also try to very early, very cautious, build some assistance to the interpreters. And one thing I remember is that the interpreters are trained to not just plain translate, but to express the general meaning clearly, so it's very nicely understandable in the other language. So how much did that conflict with your goals?
It did not conflict at all. It helps in the way that it is shorter, better segmented, and all that. We have the plan of benefiting from this later on. Unfortunately, our follow-up proposals, which directly targeted this, and we had interpreters on the board, were not yet accepted, so we will keep resubmitting those proposals. But we really have put the term machine interpretation to the project proposal, and we want to do machine interpretation, which includes all this simplification. We want to learn from the interpreters. So I'm personally learning a lot by talking to them directly. It's difficult for me and the humanities trained people to like have a common language. So they know all the tricks. They know how to train these tricks to the students, but it's sort of a craft. They learn it, but what can you benefit? How can you benefit from these tricks in an automated system? So there is still like a mismatch between even the researchers. And once we resolve the mismatch between the researchers, I'm sure that we will be able to create systems that understand the message. So actually, that is the main reason why I have broadened my scope of interest, because machine translation can be done at a very good quality without any understanding whatsoever. By bringing in the speech and what the interpreters are trained to do, you have a chance to work with the meaning. So hopefully we'll be able to model it reliably. And the task that I mentioned here, the summarization, this really requires you to understand the meaning if you want to do the abstractive in the general and correct meaning, not the technical term, the abstractive summarization. If you want to abstract away the details, then you need to understand the message. So it's a great challenge, and through challenges you learn more. So yeah.
Okay. Any other questions? Okay, let's thank the speaker again.